This video is of the notes for Friday, August 27th. We came up right here with some descriptors for shape, looked at some pictures, and we eventually make a stem and leaf plot. So first off, typically the shape is either skewed or symmetric. Now if it's skewed, there's a lot of misunderstanding here. Where is the tail of the data? So if I have a dot plot that looks like this, or a histogram, or a stem and leaf plot, let's make that a little higher right here. Then if the tail of the data, where it's tailing off at, is to the right, that's the direction of the skew. It is a big misunderstanding with people. It's kind of 50-50. Some people mix it up. The skew is where the tail is. I don't like that curve. I'm going to try better here. Try again. This pen is not working. There we go. I don't know. Still looks funny. But typically I'll just draw a smooth line to demonstrate this. I wanted to give you some dots to go off of those. So this could be a dot plot, a histogram, a stem and leaf plot. You draw a line over the distribution. Wherever the tail is, if there's a tail, that's the skew. So for left, flip it the other way, and that's left. Pretty simple. Where the tail is where the skew is. Let me write that down. Where the tail is where, or the direction, let's write that, I like that word better, is the direction of the skew. Or you have the fancy textbook definition right down there. All right? Let's move to the most common word, most used word we're going to have this year, and that is normal. So maybe the distribution is symmetric. Let's get a lot of room here. I need a space there. So this is like a break here. And we're talking about symmetry or a symmetric distribution. So normal, another word that's used is bell curve or bell-shaped. And a normal curve looks like this. Some people make the mistake of saying that has left and right skew. That's impossible. That's like contradictory. You don't want to say something is normal and skewed, because skew means it has only one tail. Symmetric means symmetric. So I would say that a normal distribution, a bell-shaped curve, is symmetric. Another descriptor for normal is mound-shaped. Some people don't like that word, but I have seen it on a test question. All right, so it has symmetry. Uniform is a very exciting graph. It's a plain old flat line. Nothing actually exciting about that. But it is used quite a bit, especially if you get into actuarial science. It's all about the normal curve and uniform distribution and a few others, but primarily those two. Bimodal, this is referring to number of peaks. And I don't know, maybe I should organize this a little better. It's not necessarily symmetric. It might be, it might not be. The ones I'm going to draw, they're going to be symmetric. But who knows? If it has two peaks, it's bimodal. Like the one we just looked at on the last video was multimodal with some symmetry. So bimodal, I don't know, maybe it looks like this. And multimodal, maybe something a little out of control. like that. All right, hopefully that helps. We'll talk a lot about the normal curve. We have a lot to talk about with that. Many variables follow the normal distribution. Heights are normally distributed typically. People's IQs, certain types of test scores are normally distributed. You're going to get tired of me hearing the word, me saying the word normal. So, all right, let's make a graph, a stem and leaf plot, and we'll call it. So in third period, we all sat and thought for a minute, went into our shoes closet in our head, and tried to remember how many pairs of shoes we have. Seventh period did it too, but here's third periods. And there they all are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 people that day. That was Friday. We're going to make a stem and leaf plot, or just a stem plot. You can call it both, stem and leaf, stem plot. The first thing, the big decision you need to make is, what is your stem? I'm talking about place value. What place value are we going to use for stem? Because I'm going to draw a vertical line here. And the left side is going to be my stem, and the right side is going to be my leaf. And typically, the most common stem you pick is the largest place value represented. So for example, if you look at 18 or 22, that goes out to the tens place. 5, that's only the ones. That's not very helpful. And what you do is you write on the left that place value, least to greatest, that is represented. 5 still has a place value in the tens place. It's a 0. Now, don't write this, but I just want to show you how I could maybe poorly do this. What if I write a 0, a 1, and a 2 for my stem? That's not going to tell me much. I could make a dot plot out of this data, and I would see some shape to it. When I make the stem plot, I want to be able to see a similar shape. If I have a stem like that, I'm going to have a few numbers here, a few numbers here, and a few numbers here, and it's forced to be symmetric because it's so condensed to those 3 stems. So what if I get creative? And it requires that. You got to be creative with your stem sometimes. And ask yourself, what would cause this thing to spread out some? What if I split the stems, or split the stem of tens to a low and high? So what I mean is, let's look at the tens stem. So, like we got a 11, we got an 18, we got a 10, an 11, a 10. So what if I do a 10 low and a 10 high? This stem will resemble numbers 10 to 14, and this will resemble numbers 15 to 19. Only I don't want to write the actual number 10 over there on the left. Let's change that to a 1 to resemble tens. So let's abbreviate even more, and let's represent all the stems. So we have a 0 low, we have a 0 high, we have a 1 low, and we have a 1 high. We have a 2 low. Do we have a 2 high? We don't. In 7th we did. We had a 27. So we made a 2H. I don't see one here. Oh yeah, we do. We have 25. So 2H. So in other words, I want there to be a potential 5 possible numbers, 5 a range of 5 for each stem. So that 0L represents 0 shoes to 4 shoes. And I'm just going to go through the numbers and mark off as I go and write them to the right. So that 5 goes right here. The next 5 goes right here. And then this next part looks weird. For 21, I just write a 1 right there. Since it's on 2L, I know that 1 resembles 21. Rewind it if you need to, and listen to how we do this if you get lost. We got another 5. We got an 11. A 22. This is weird. So that does not represent 12. That resembles 21 and 22. We got an 18, an 8, an 8, a 20, a 22, a 4, an 11, a 10, 7, it won't cross out, there we go. Where are we? I got lost. A 4, an 11, a 3, a 25, a 7, a 10, and a 6. All right, so if you wrote them out on a piece of paper, I can't do it on the screen, but turn your paper sideways so that the stem is on the bottom and you can see a shape. And I would say that this, I would say that this is tailing to the right. Has a positive skew or a right skew. All right, so let's practice describing, and maybe hit pause on the video, write your description, and see how well it matches mine. The median is the average of the 11th and the 12th. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, that's tricky. Did I count right? We have 22 numbers. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, so that's frustrating. 3, 4, 5, 6, 7, 8, 9, 10, 11. So the average of 6 and, whoops, I counted wrong, didn't I? The average of 8 and 10, so the median is 9. All right, here we go. The median number of shoes for third period AP Stats students is 9 pairs. Let's move to shape, so that's the center. The distribution is right skewed or positive skewed with a, let's say, the highest peak at 5 to 9 and a second at 20 to 24. Shoes range, or number of shoes, range 4 to 25. I didn't really think there's anything unusual. I don't think that 25 is an outlier because there's not a big gap between it and the one before it. It wouldn't be wrong to say that there's a big dip in the 15 to 19 range. That could be unusual. If you said that, that's not wrong. I don't know. It's just not standing out to me. It's not alarming. So I'm not going to say anything unusual. All right. I hope that was helpful. See you in class.